You walk into a room you have never entered before. A conversation starts, and somehow you already know what the next sentence will be. For half a second, you are certain this has happened before. Not similar to before, not reminiscent of before, identical. Then it's gone. Nearly 2 out of every 3 people on Earth will have this exact experience at some point in their lives. Scientists have a name for it: déjà vu, French for already seen. And for over a century, they dismissed it as unexplainable. That has changed. Neuroscientists have now triggered déjà vu on command in a lab and watched it happen inside a functioning human brain. But here's what almost never gets said out loud. Even the researchers who did that experiment will tell you, they've only explained part of it. This is what we actually know. What we don't, and what people still choose to believe anyway. Act 1. What science currently supports. For most of the 20th century, déjà vu sat outside the reach of experimental psychology for a simple reason. It's unpredictable. It lasts seconds. You can't schedule it, and you can't reliably ask someone to have one on cue. That made it almost impossible to study, until researchers stopped waiting for it to happen naturally and started trying to manufacture it. Anne Cleary, a cognitive psychologist at Colorado State University, has spent roughly 2 decades doing exactly that. Her starting point was a related and slightly more tractable phenomenon: the feeling that a word is on the tip of your tongue, knowing something is stored in memory without being able to pull it out. Cleary's hypothesis was that déjà vu works the same way, but with scenes instead of words.
Scientists have largely assumed that déjà vu is too rare an occurrence in real life to be investigated experimentally or to duplicate in a laboratory setting. I wondered if this was actually true. There's a very similar type of subjective phenomenon that you may be familiar with. It's called the tip of the tongue experience. The tip of the tongue experience is when you feel as though a word is right there, on the tip of your tongue, about to be recalled, and you can't quite access it. Researchers have been studying tip of the tongue experiences for many decades, and the way that they do this is to create circumstances in the laboratory that are hypothesized to produce tip of the tongue experiences, and then to have people self-report on when they're experiencing tip of the tongue and when they're not, in order to test these hypotheses. I wondered if the same approach could be taken with déjà vu. So for example, why couldn't we create the type of spatial resemblance that's shown here in this figure in a laboratory setting and have people self-report on when they're experiencing déjà vu in order to test this hypothesis that spatial resemblance can produce déjà vu in the absence of recall of the source?
To test it, her lab put participants inside a virtual reality environment. Subjects were guided through a series of virtual spaces, say an aquarium, a junkyard, a garden, and asked to simply move through them. Later, they were guided through a second set of spaces. Some were entirely new. Others were laid out with the same spatial arrangement as a space from the first round, even though the visual theme was completely different. Different walls, different objects, different lighting. Participants had no conscious memory of the earlier, spatially matching scene. The result? When a new scene secretly shared the layout of a previously seen one, participants were significantly more likely to report déjà vu, even though they could not identify why the space felt familiar. Cleary's conclusion, published across multiple peer-reviewed studies, is that déjà vu is generated when the brain detects a strong resemblance to something in memory, while conscious recall of that original memory fails. The similarity gets through, the source doesn't. That explains where the feeling of familiarity might come from. It doesn't explain the unsettling part, the awareness in the same instant that the familiarity is wrong. For that, the clearest experimental evidence comes from Akira O'Connor and his team at the University of St. Andrews. In 2016, O'Connor's lab used a modified version of a classic memory test called the Dease-Roediger-McDermott procedure. Participants were read lists of closely related words: bed, pillow, night, dream. But the one word that ties them all together, sleep, was deliberately left out. Later, participants were asked whether they'd heard any words starting with S. Most said no. Then, when asked directly whether they'd heard the word sleep, they realized correctly that they hadn't, and yet it still felt familiar. That collision, a strong pull of familiarity paired with certain knowledge that the familiarity can't be right, produced the déjà vu sensation in the lab, reported directly by participants during the session. The researchers scanned participants' brains during this process with fMRI. If déjà vu were simply a memory retrieval event, they expected to see activity in classic memory regions like the hippocampus. That's not what they found. Instead, the regions that lit up were the frontal areas associated with decision-making and conflict monitoring, particularly the anterior cingulate cortex and medial prefrontal cortex. Déjà vu may be a sign that your memory system's error-checking process is working correctly. Frontal regions appear to review what the memory system is producing, detect an inconsistency, and flag it. And that flagging is what you experience as déjà vu. Not a glitch, a memory system catching its own glitch. There's a second, older, and in some ways more dramatic body of evidence, and it doesn't come from healthy volunteers at all. It comes from the operating room. Beginning in the 1950s, neurosurgeon Wilder Penfield, operating on patients with epilepsy at the Montreal Neurological Institute, applied mild electrical current directly to the exposed temporal lobes of conscious patients during surgery, a technique used to map brain function before removing seizure-causing tissue. Some patients, while the current was applied, spontaneously reported the sensation of déjà vu, described in real time on the operating table. Later work by French neurologist Jean Banco in 1994 and by Fabrice Bartholomé and colleagues in 2004, using intracranial electrodes, refined where in the temporal lobe this happens. Bartholomé's team found that stimulating the rhinal cortices, a set of structures bordering the hippocampus, produced déjà vu more reliably than stimulating the hippocampus or amygdala directly. Stimulating the entorhinal cortex specifically tended to produce déjà vu. Stimulating the neighboring perirhinal cortex tended to produce a different sensation, the reliving of an actual identifiable memory. People with temporal lobe epilepsy is important because a meaningful subset of them experience déjà vu as a warning sign, an aura, at the very onset of a seizure, every single time, with a consistency healthy people never have. Their testimony, recorded across decades of case studies, is some of the most detailed first-person data scientists have on what déjà vu actually feels like from the inside. So, 3 independent lines of evidence converging on the same territory: a virtual reality behavioral study, a controlled fMRI experiment, and decades of direct electrical stimulation in surgical patients. All 3 point toward the same general system: the medial temporal lobe and the frontal regions that monitor it, working together, occasionally producing a false positive on familiarity that your brain then flags as an error. That is what the evidence currently supports. It is not, however, the whole picture. Act 2. What remains an open question. Here is where the documentary version of this story usually ends, with a tidy answer. But ask the researchers themselves and the tone changes. The first open question is a basic one. Why frontal regions and not memory regions dominate the déjà vu signal is still debated. O'Connor's team has proposed it reflects a conflict detection system rather than a memory retrieval one. But that's a hypothesis built on a lab-induced analog of déjà vu, using word lists, not the real, spontaneous experience most people have while walking through an actual unfamiliar place. Whether the artificial version in the scanner and the real version in daily life are generated by identical mechanisms has not been definitively established. The second is about age. Survey research, most notably a large body of work compiled by psychologist Alan Brown at Southern Methodist University, has consistently found that déjà vu is reported far more often by people in their teens, 20s, and 30s than by people over 60, and more often by people who travel frequently or have higher levels of education. The correlation is well documented. The causal mechanism is not. Leading theories point to natural declines in memory precision with age, reducing the false alarm opportunities that produce déjà vu. But this remains an inference, not a confirmed mechanism. The third question is stranger, and it's one Cleary's own later research opened up rather than closed. In follow-up experiments, she found that some people, during déjà vu, don't just feel like they've been somewhere before, they feel like they can predict what happens next. In one of her studies, participants navigating a virtual path that secretly mirrored an earlier, unrecalled path reported significantly increased confidence that they knew which direction the path would turn, even though, when tested, their actual prediction accuracy was no better than chance. The feeling of premonition was real and measurable. The predictive ability behind it was not. Cleary's own conclusion, published in Psychological Science, the sensation of foreknowing during déjà vu appears to be illusory. But why the brain manufactures a false sense of prediction on top of a false sense of familiarity is not yet explained by any current model. The fourth is about people at the edges of the bell curve, the roughly 1/3 of the population who report rarely or never experiencing déjà vu at all, and the small clinical population, mostly with temporal lobe epilepsy, who experience it dozens of times a week. Both groups exist within the same broad framework of memory conflict theory, but no model yet accounts for why the frequency varies so dramatically between individuals with, as far as anyone can tell, structurally normal brains. And there is a more basic limitation underlying all of it, one that neurologist Adam Zeman has pointed out directly. We have detailed intracranial recordings from epilepsy patients because those patients are already undergoing invasive monitoring for medical reasons. We do not have equivalent recordings from healthy people having an ordinary, spontaneous déjà vu experience in daily life, because no one is going to implant electrodes in a healthy brain just to catch one. That means a genuinely important piece of the healthy brain story is, and may remain, out of reach. So the honest scientific position, as of today, is this. Researchers have identified a mechanism that reliably produces a version of déjà vu in controlled settings, and strong circumstantial evidence that a related mechanism operates during spontaneous, everyday déjà vu and in epileptic auras. What they have not done is prove these are the same mechanism, explain why it varies so much between individuals, or account for the false sense of premonition that sometimes rides along with it. Act 3. What is philosophical speculation? It's in that gap, between what's proven and what's merely plausible, that the older, stranger explanations have always lived. And it's worth being direct about the fact that none of what follows has experimental support. This is not science. It's the set of ideas people have reached for across centuries to fill the same gap neuroscience is only now starting to close. The oldest is memory of a past life. The idea that déjà vu is a fragment of an experience from a previous existence, surfacing without context. It has no basis in evidence and no plausible physical mechanism, but its persistence says something real. People consistently experience déjà vu as too specific, too detailed, to feel like a simple coincidence, even when, per the research you just heard, that specificity may be manufactured entirely by the brain's own error-checking process. The second is the precognition or psychic hypothesis, the idea that déjà vu is a genuine glimpse of the near future. This is the belief Anne Cleary's premonition experiments were specifically designed to test, and the data ran against it directly. Participants felt they could predict what came next during déjà vu, but they could not actually do so at a rate better than chance. The feeling of prediction was demonstrated. The prediction itself was not. The third and the most modern is the simulation or glitch in the matrix hypothesis. The idea that déjà vu is a visible seam in a simulated reality, a moment where the system reloads or repeats a rendered scene. It's a compelling metaphor, partly because it happens to describe the neuroscience almost perfectly by accident. A system generating an output, catching an inconsistency in that output and flagging it. But the brain functions somewhat like error-checking software, is a description of a cognitive process. It is not evidence that reality itself is software. The fourth is the parallel universe hypothesis, the notion that déjà vu marks a brief crossover or bleed-through between adjacent timelines. Like the simulation idea, it has no testable predictions attached to it and exists entirely outside the domain science can currently evaluate. What's worth noticing is not that these ideas are foolish, it's that they all reach for the same missing piece. A satisfying account of why the feeling is so overwhelming, so specific, and so certain, even after you know, immediately, that it can't be real. The neuroscience explains the mechanism. It hasn't yet fully explained the intensity. That gap is exactly where speculation moves in, and probably will keep moving in until the mechanism is mapped in far more detail than it is today. So, what is déjà vu? It is, as far as the evidence currently shows, your brain's memory system checking its own work. A scene, a sentence, a hallway resembles something already stored away closely enough to trip a familiarity signal, while the specific memory behind that signal stays out of reach. In that gap, frontal regions of your brain appear to step in, notice the inconsistency, and flag it. What you feel for 2 or 3 unsettling seconds is that flag going off. It has been triggered on command in a scanner. It has been produced on an operating table with a small electrical current. And it has been reported in strikingly similar terms by people from Colorado State freshmen wearing VR headsets to epilepsy patients on the eve of surgery, decades apart, describing the same sensation in nearly the same words. That is a real, replicated, published scientific result. It's also, by the researchers' own admission, incomplete. Nobody has yet explained why some people barely have it and others have it constantly. Nobody has fully explained the false sense of prediction that sometimes comes with it. And nobody has recorded directly what's happening inside a healthy brain during a spontaneous, everyday déjà vu, the exact experience that made you click on this video in the first place. which means the next time it happens to you, walking into a room, hearing a sentence you swear you've heard before, you'll know something most people never learn. That feeling isn't a glimpse of another life or a crack in the simulation. It's evidence that for one brief moment, you caught your own memory system checking its work in real time. Science answered most of the question, not all of it, and that's usually where the more interesting part begins. All of the sources and references used in this video are listed in the description below if you'd like to explore the research for yourself. If you enjoyed this kind of deep dive into science, philosophy, and the mysteries of the mind, don't forget to like the video and subscribe for more. Now I'm curious about your opinion. What do you think déjà vu really is? A simple glitch in the brain? A trick of memory? Or something science hasn't explained yet? Leave your thoughts in the comments. I genuinely love to read them. Until next time, stay curious.